All right, mathletes, here we are looking at enlargements and reductions. When we're talking about enlargement and reductions, we'll talk about scale factors. Okay, so a scale factor that is greater than 1, okay, is going to give us an enlargement. Okay, so it's, when you think about scale, it's a factor, so it's multiplication. So if we multiply something by it, it's going to enlarge it. Okay, and we multiply something that's less than 1, which is similar to division, we are reducing that. Okay, so if we were trying to define a enlargement and a scale factor of A to B, where B is the image, we can look at our side lengths. So we can see that this A was a side length of 1, this side length was a side length of 2. So what scale factor do you get to get from 1 to 2? Well, that would be a scale factor of 2. Okay. If we were trying to do a scale factor of A to image C, we can see that's 1 to 3. Okay. And that would be a scale factor of 3. And notice also the other side, so A was a scale of 2 here, length. So if we multiplied by a scale factor of 3, it'd be 6. And sure enough, we can see that this length was 6. Okay, so if we wanted to do a reduction, and let's say if we wanted to go from C and our image would be B, okay, we went from 3 to 2, okay, so we would have a scale factor of 2/3. Okay. Also with enlargement and reductions, we don't even also need to talk about the center of enlargement. So we see that here we have an example in A, B, and C of three different centers of enlargement. Okay, they all have a scale factor of 3, so we can see that they are getting larger. Okay, from P to P prime, Q to Q prime, and R to R prime. Okay, but their images are in different locations because the center of location is different. Well, to find our center of location, what you want to do is you want to be able to draw a ray starting at your image, okay, and going through the corresponding point. So from Q prime to Q, and keep that ray going as long as it will go. Okay, and then you do P prime to P prime, and R prime to R, and keep that ray going. And where those lines intersect will identify, okay, your center of enlargement. Okay, so doing that again, I can do, well, this one is pretty Q to Q prime, R to R prime, and again it's a ray, so just keep it going. And P to P prime, if your image is the same location as original point as it is with P and P prime, by default that will be your center of enlargement. Okay, so in example C, we can do that again, and Q to Q prime, P to P prime, and R to R prime, and they should have a concurrent intersection. So we can see right there is our point of the center of enlargement. Okay, in our last example here, we're going to find the image given our scale factor and our center of enlargement. Notice our center of enlargement is defined by that point O. Okay, so on A, we are going to enlarge it by 2. So what was 1 times 1 by 2 is 2. What was 2 is now going to be 4. And there in the blue is our image. Okay, in part B, okay, this one, since the center of enlargement is off, I'm going to draw my rays, and I'm going to go from each vertice. Make sure that they are drawn nice. I'd suggest using a ruler when you're doing this in your problem sets. And also identify the slope that you're recognizing that these rays are creating, because that's going to have to stay consistent. Okay, so that distance, so if I look here, this distance is 1 away. So if I'm doing a scale factor of 3, this point that was here, let's just call it point L. L prime, which was 1, L was 1 away, so L prime is now going to be 3 away. So that is my new corner point. And this side length was 2. So now, with a scale factor of 3, that side length needs to be 6. Okay, so it's off a little bit just because of my smartboard here and not getting it truly here, but with a straight edge and a ruler, you'll have better success with that. Okay, I also see that one reason that it wasn't right was because that side length should be 6, so it should goes down all the way like that. Okay, and again, I can kind of look at my steps. So before it was down 2 over 1. So if I do that 3 times, okay, 2, 3 times, I can also see that point there. And then now I have enough points here where I can say that this would be the image of the previous one. Okay, now with C, we got a scale factor of 1/2, so I know it's going to be smaller. Okay, so I'm going to, again, draw my rays off of some of these points to help me. Try and line them up a little bit more appropriate. And then from there, I need to know that everything is going to be half of what it was before. Okay, so this point here was 3 away from my center of rotation, so half of 3 is 1/2, so I'll be right there. Okay, and this point that was here was up 2 over 3, so half of that is going to be up 1 over 1/2. Okay, this point here is going to go back, and it's going to be, that's 2 away from my center, so it's going to be 1 away. Okay, and then again, I'm going to use symmetry, as this is a symmetric object, to kind of get my other points. Okay, and from there, I can get my new object. Be like that. Okay, so that would be with a scale factor of 1/2. Okay, that concludes our notes for tonight. Please highlight any questions you may have and bring them to class tomorrow.